Welcome back. Now we have mastered enums and pattern matching for modeling data. Now let's explore how to work with collections of data efficiently and safely. Rust's standard library provides powerful collection types that are both fast and memory safe. Today we will discuss about the vectors, then we will discuss the strings, followed by the hash maps, which are used for the key value paired data storage, and followed by we will then compare their performances with each other, and lastly we will check out some real world collection patterns. Collections are essential for almost every real world application. Rust's collections come with strong ownership guarantees and excellent performance characteristics, and these collections will prove useful for you in various requirements. Hence, each one of them holds significance. So let's dive into it and check them out. In reality, there are various ways to create the vectors. First of them is like this: let MUT1 colon VEC, then the data type specification, and here I take it as I32 is equal to VEC colon colon new. So this creates a empty vector with a explicit type annotation of I32, and another variant is like this: let V2 is equal to VC, and the values inside it 1 2 3 4 5. This is the macro for the direct initialization of the vector when we create it. And the third variant is by specifying the capacity of the vector. So let V3 is equal to VC with capacity 10. So this defines a vector who can store the 10 items into it. So it actually pre-allocate the capacity beforehand, and after it you can then push the elements into it to store the values. So for example, for pushing new data in these vectors, use the dot push operator. So you after the dot then write the push method inside parentheses, specify your value which you want to push. Similarly, v2 dot no, 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 v1 dot push 20 and 30. So after these three operations, v1 vector will have the elements 10, 20 and 30. Let's check now by printing them. Let's quickly compile it. Rust C vector dot arrays. Here I got an error because I didn't write these into a main function. That's why the compiler considering them as the global variables. So let's fix this. Let's recompile it. Oh, so I missed here the type annotation. Let's fix it quickly. VCI32 and recompile it again. Finally, it got compiled. Vectors.exe got the values here: v1 10 20 30, v2 1 2 3 4 5, and v3 has the capacitance, but right now there is no value inside this. When you have to access the element, uh, then follow the uh, a proper syntactic rule. So let third element equal to ampersand v2 and index 2. So this is here I am accessing the third element in the v2 vector, and the third element in the v2 vector is actually 3. Since the indexing starts from 0 for this vector, first element index is 0, second one is the index 1, and so on. So when printing this third element, I would get the 3 as the value for the third element variable. Uh, but note that this is not a safe way to access the elements of vectors using the indexes. For the safe usage, follow the match expressions. So for the match expressions, follow these syntaxes. For example, if I want to access at the index 2, write it as follows: match, then v2 dot get, and inside parentheses specify the indexes, then inside the braces uh, write the first variant of the option enum, which is the sum value. If the value is present at the index 2, it got returned here, and if no value is present at the specified index, then that would be processed in the none pattern of the match expression. Similarly, if on the v2 vector I want to access the element at the 10th index, but since the v2 vector is having only 5 elements, this would surely throw an error if I have used this through this method. Then here the using the pattern matching via the match keyword will gracefully handle this error situation, and you would get a print uh, in your terminal that no 10th element exists. So this is how you must handle the index out of bound situations in the vectors. And note that vectors are just dynamic arrays. This means that they can grow and shrink as needed. Notice the two ways to access the elements, which was the through the indexing method or through the dot get method. Dot get method also returns the values at a specified index. So this is how the elements are accessed in the vectors, and for the putting values into it, use the push method. For iteration over the vectors, there is also a set of syntaxes. For that, let me illustrate you with a code snippet. So first of all, I have declared a vector here, and similarly, I have used a simple for loop to iterate over these numbers vector. And syntaxes goes like this: first of all, the for keyword, then specify a variable which can hold the individual elements of the vector. Use the in keyword, And lastly, specify your reference to the vector, uh, which will help the for loop to iterate over each of the elements in the vector. And lastly, inside the loop, write the print statement or keep any processing statement here to process the individual elements. If you want to double or each of these numbers in the vector, then iterate over the numbers vector, but provide the mutable references so that the individual numbers can be updated. And with the star operator, uh, access the individual element and then multiply them with the 2 and store the updated value in them. In addition to these, vectors also provides you the methods through which you can do the iteration. The dot iter method is a built-in method in the Rust through which you can iterate over the vectors. So as an example, here I have iterated over the numbers vector and applied the sum method onto them to sum each of these elements and store the total sum in the sum variable. Similarly, for multiplying each of the individual elements with the number 2, you can iterate over the numbers vector and map them with the to the map each of the elements to the new vector and multiply them with the 2, which is done here, and lastly collect them uh, as a vector here. So ultimately this entire statement will return a new vector which will have the each of the elements as the multiplication of the original numbers by 2. Similarly, for the extracting the even numbers from a given vector, you can iterate over them and provide the filter method and lastly collect them. And then you can verify them by the printing. And other operations also exists in the vectors for removing the elements or inserting new elements at a specified index, etc. So for removing the last elements from the vector, use the pop method, dot pop uh, syntax on the existing vector. Then if you have to update or the insert a new element at the at a given index, for example, if you have to insert a new element at the index 1 and new element is 25, use the insert method. And for removing an element at a given index, then use the remove method and inside the parenthesis provide your index at which you want to remove the element. Sort method automatically sort the numbers in your entire vector. If the vector is holding the strings, then the strings will be sorted based on the alphabetical sequences, and you can reverse the entire vector with the reverse method. Reverse will changes the indexes of the vector. The last element of in your original vector will become the first element in the updated vector, and so on. The second last will become your second element, and so on. So after these operations, you can then print them. Let me show you by printing it. CLS So rest c vectors dot rs vectors dot txt, and hence I got all the values here. So these are the all set of operations that you can apply on the vectors. Vector always store the data elements having the same data type, but smartly you can store the different data type elements as well in the vector. For that, you have to use the enums. Uh, in the enums, you can specify your data elements having different data types, like done here. I have created the spreadsheet cell named enum, into which I am having the data type data of the data types integer, float, and text, and later I have created the row vector into which I am giving an integer data type value into the vector, and then float value followed by the string, and again the integer value. All these are part of the spreadsheet cell enum, hence referencing the spreadsheet cell is also required here, and followed by then I have iterated over each of the rows here, and the individual elements in the row vector I have named as a cell here. On each of these cell I am checking uh, on the specific data elements that whether uh, which one of them actually matching the integer pattern, float pattern, or the string pattern. So this is how you can work with the different data elements stored in the single vector. Storing elements of different data types can also be done by using the trait objects, and this is a quite advanced topic, so I will cover it later. Let's now switch to another topic. Next, we will check about the strings. Let me create a new file first, strings.rs, and I'm writing the pre-written script into this. So first of all, I'm creating a new string, and onto which I'm providing defining it as a mutable string here, and the s1 is actually an empty string because I have didn't provided any values, and I have can directly initialize a an s2 string. So this is holding the initial contents value, or there is a third way to define a string using the string from method. Inside the from method, you can write your uh, given string into this and get it stored into the s3 variable. So since the s1 is a mutable string, we can update its value, and for updating, you can append the new values into them using the push str method. Push str method takes from you the new string which you want to push into the original string, or you can use the simple push method to actually use append the single character into the original string, or you can use the plus operator. Plus is equal to operator will uh, sum the two strings, and whatever sum will come out will get stored into this sum as one. So for example, if s1 is hello, and plus is equal to means that do the first of all plus apply the plus operator first of all, then apply the is equal to operator. So for the application of S1, so the plus is equal to actually denotes this sequence. S1 is equal to S1 plus and how are you. Since S1 is hello, so hello plus how are you will become hello, how are you. Hello, how are you? So this is what the updated value would be in the S1 string. Then you can check them by printing all of them, and you can concatenate the multiple strings using the plus operator or your specified uh, whether you can create the spacings between them, or you can either apply comma uh, to separate each one of them logically. So this is how you must work with the concatenation with the usage of plus and is equal to operators, or there is the format method to apply the formattings into your text. So its syntax goes like this, that inside the double quotes give the parenthesis onto which you want to put your specified strings, and the spacings between those strings will occupied by this uh, text which I have highlighted here. Then you can check them by printing these. Also, format method do not affect the ownerships of any of the strings it took as a parameter. So S1, S3 will still be valid after the usage of the S5. There are multiple utility methods in the string using which you can read the elements, write the elements efficiently, or you can uh, calculate some of the patterns found into them. So in this sequence, for example, I have created here three strings, the hello and word and the story and emoji. This one is the word written in the Chinese language. So for the calculating the number of characters in the string, you can use the len method. You can directly apply on the given string with the dot operator, and dot chars actually return an iterator over the uh, original string. With those iterator, you can either count each of the characters with the count method, or you can apply any other operation here to serve your purpose. Similarly done for the word string and emoji string as well. Uh, so the both of them, the length alien method calculates the length of the string, and with the chars and count, the number of characters will be counted, which is at both of them return the same value. You can iterate over the strings with the for loop as well. For example, I'm iterating here onto the word string, and when for loop iterates over a string, then in each of its iteration, it actually operates on the individual characters inside that string. And you can calculate the bytes in the given string as well by following this syntax for b in world.bytes. Bytes method returns an iterator over the world string, and onto those iterators, the for loop process each of the individual elements and store them into its internal variable named as b, and then printing it here each of those values named as b. For slicing on the string, uh, for example, onto this S string, you have to apply slicing, then proceed like this, ampersand S, and inside the square brackets, specify your left and right side indexes to take out the substrings uh, or say the slices from the given string. For actually processing these strings safely, you must surely use the option enums. You can either use with the match expression or through the iflet uh, to actually check out that whether the indexes you specified is actually exists or not. This will let you safe handling of the slicing from the string. Here I have compiled the multiple string methods for you. The contain methods checks that whether the provided string exists in the original string or not. It starts with check that whether the given string it starts with the provided string or not. Ends with checks that whether the provided string is the last word in the given string or not. Replace method helps you to replace uh, an individual string to be replaced by another string. The updated string should be placed on the second index, and at the first place, the string that you want to be replaced will be kept. To uppercase, uh, it escalates the cases of individual characters in the provided string, and the lowercase lowers down the cases of individual characters in the given string. And trim method uh, removes the extra spaces or the white spaces in the given string. So these are some of the common methods you can use the strings in these strings for the efficient string processing. Let's now explore the hash maps. Hashmaps.rs. So let me illustrate you with a code snippet here. For creating a hash map, you must use the new method, and if you want to update the values in the hash map, you must specify the MUT keyword onto the variables which are storing the hash maps. For inserting new values in the hash maps, insert method are used. This insert method will take two values from you. First one will be the key part, that at what key you want to update the value. So here I am creating a key here in this scores named hash map. The first key is the blue, and at the blue key the value 10 is stored. Similarly, new key is created named as a yellow having the value 50, and for the key red value 25 is stored. You can print this scores hash map to verify whether the values you inserted got successfully stored or not. You can access the values at a specified key by providing the key name into the get method. The get method is used to access the elements at a specified key, and later you can then uh, specify the pattern matching on this blue score or to check that whether you got actually the valid value or you got the null or some invalid references which you can then get it processed in the none pattern. For iterating over the hash maps, for loop could be useful. Uh, for successfully iterating over it, you must iterate over the reference on the scores hash map. Since the scores hash map is having the key value pairs, so you must extract out the tuples from there, uh, and in that tuple, your key and value will be stored here. Later, you can print them or process them, each of those key values. With the insert method, you can also update the value at an existing key. For example, for the blue key, I had given the value 10, but now I want to update its value to 25. So I can provide the updated value into this. However, the updating value with the insert method is error prone because if the key might not be existing in the hash map, then this will surely throw an error. For the safe handling, you must use the entry method with the or insert method to safely insert a value at a given key so that if the key do not exist, uh, it do not throw an error or do not crash your program. So in the entry method, you specify your key and or at the or insert, provide your value that you want to be updated at the specified key in the entry parameter. Lastly, you can print the scores hash map to verify with the provided values. So before using any collections in the Rust, you must surely consider their performance characteristics before using it. So for the vectors, these are useful in the cases where dynamic arrays or sequences are required. The time complexity of read and write operations are order 1. That means it takes constant time to write or read values from it. And the memory it occupies, it's compact, it's not create much overhead on the memories. While the strings are useful for the text data where you have to process the multiple texts from generating in your application. Its time complexity is order 1 for reading the data, but when you have to update the values into it, uh, the write operation becomes costly because its time complexity is order n, where n is the length of the string. And The characters string stores is encoded in the form of UTF-8 encodings, and however it is optimized for the efficient storage of the Unicodes. So remember that strings are only useful where character-based or text-based requirements to be served. And hash map collections is useful where you have the requirements for saving a key value pairs to for the further processing. The reading of the data from the hash maps is also constant. Its time complexity is order 1 for the average lookup cases. However, the spaces memory it occupies creates an overhead when the large amount of uh, data is to be stored in the hash maps. Hence, it is costly on the memory of your application. So these are the some of the performance aspects that you must consider before using any of them. Let me show you some of the best practices that you must consider while using the collections. Best practices collections.rs. So first practice is that always pre-allocate the capacities uh, into your newly created vectors so that you can know the its sizes beforehand, and hence you can accordingly proceed with the updation or the reading of the data, and use the strings for the texts which are actually owned by you. Otherwise, if the text is borrowed from another functions or the processes, then use the ampersand str. And third practice is best when you have to update a new value at the given key in the hash maps. In that case, use the entry and or insert methods because this will help you to update the value at a given key safely, and hence you will not get any errors corresponding to the keys in the hash maps. Also, choose the right collections for your job as per your requirements. Use the vectors when the elements in your sequences or say in your list, the order of those elements actually matters, and hence you cannot change the order. But and in the hash maps, the only concern for you is the efficient and fast access of the values, and orders doesn't matter in that case. So in that scenarios, hash maps will prove useful for you. And whenever you are working with the texts, the strings will be useful for you. And when you are have to process a hash maps, then avoid creating unnecessary clones onto it because the hash maps brings with it the memory overheads. So creating the clones onto it will slow down your application. Hence, avoid the cloning the hash maps. Instead, use the references on the hash map collection like this here. We are taking a hash map as a parameter here, and the reference on this hash map is passed, and we are directly With that reference, we are directly accessing the elements on the user's hash map. We are not cloning this. Hence, it is a efficient processing of hash maps. In our next video, we will dive into error handling in depth, and we will learn about custom error types and how to create the robust fault-tolerant Rust applications. The tools we discussed above will be the building blocks for almost every application you write, and remember that choose the right collection for your use case and leverage Rust's ownership system for the safety. If you have questions about collections or want feedback on any of your homework related to the collections we discussed above, drop them in the comments. Like and subscribe if you are building your Rust skills, and I will see you in the next video. Thank you.